I have brought the second lecture for alcohol, phenol, and ether right now, which is going to be about nomenclature. And this involves, IUPAC nomenclature mainly, and it's for the alcohol, phenol, and ether. Because what previous video I did was that was about nomenclature of that was about classification and definition of the alcohol, phenol, and ether. And hopefully it did help you. In case it did, so this is going to be the very next topic. In case you follow your syllabus and you see everything right from the NCERT. So what I've done here already, I've taken already some example here. These examples are actually from the NCERT book. I thought I should also cover some of the questions from NCERT. So if I could have taken more examples, this I've taken the all space. So this is the maximum I could take from NCERT. So what I'm going to do right now, I'm going to take this example and we'll do from the basics, how they are named and how actually the IUPAC name is going to be coming out here, right? So let's start with the nomenclature of alcohol, phenol, ether. I have a couple of examples from NCERT, like I said. So I'm doing the first one, right? Let's, the first thing, if you remember, I've told you in previous video, like that was in haloalkanes and haloarine. What three things you have to consider is very important. You have to find longest chain. You have to find longest chain of the carbon. Longest chain of carbon with functional group. With functional group. So this is the first thing you have to do. Second thing, you need to make sure that you do the numbering of carbon atoms in such a way that the carbon having functional group, I'm writing in short, having functional group gets the lowest number, and then third, using order of priority, the naming should be done. The naming has to be done. Right? So these are the very important things you have to consider while doing any nomenclature. Let's start with the first one. So like I said earlier, I'm not concentrating over hydrogen. So what I'm going to do, I'm going to wipe the hydrogen off, right? I'm going to wipe hydrogen off so that you get a real clear picture, what I'm trying to do and what you will be trying to get it. So I have, removed all the hydrogen. Now what you have is only the carbon, right? You have only the carbon here. But this is going to be a simple, compound where there is no functional group, only the alkyl groups are. So as per the example, this is not even alcohol. So what I'm going to do, I'm going to place some, functional group here. So let's put some OH group anywhere. Maybe I should put some OH right here. So I placed a couple of functional group over there. Right? Let's start the naming here. As you can see, the longest chain is 1, 2, 3, 4, 5. That is the longest chain here. Take any other option. 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So the longest chain I get is 5. So I'm going to circle that, longest chain so that you understand exactly what I'm trying. So this is the longest chain. And one carbon outside the chain is methyl. So this is also methyl, this is your alcohol, this is your methyl, and this is also your alcohol. So this is the parent chain. This parent chain will be called pentane because there are 5 carbons, right? These are methyl hydroxide. But let's name it. So after you have the longest chain, what you need to do, you need to number it. So how I'm going to number it? I'm numbering, looking at the functional group. So what I see, OH is right here. So let's see 1, 2, 3, third. On third carbon, the OH are present, and from the right side, the OH are also present on the third. So the question is, where should I start with? either in clockwise direction or in anti-clockwise? The answer is, since from the anti-clockwise you have two branches here. You have two branches on the second, but you have one branch on the first. So preference is given to the branching, number of branching actually. So that's what I'm going to do. So I'm going to give priority to the branching here, and I'm going to write the name. So let's see what this is. That one is like 1, 2, 3, 4, and 5. So what we see on the second carbon and on the fourth carbon, you have methyl. So I'm writing 2, 2, and 4. Trimethyl, right? For these three, 1, 2, and 3. And then on the third, there are two hydroxyl group. So this is going to be like trimethyl, pentane, 2, 2, 3, 3, because they are on the third position. 3, 3, diol. That's it. So that's the IUPAC name of this particular compound. Right? Let's do the next one, and then that's going to be easy. So what I have to do, in order to make it less chaotic and more visible, I'm wiping this very first example. Right? So I have to do that because I need to create space. Okay. Now concentrate on the second one. Like I said earlier, I'm not taking tension about hydrogen, so I'm wiping the hydrogen off. Right? I'm wiping the hydrogen off here. You just also have to do, in case it helps you, you can do. But don't wipe the hydrogen off from a functional group, only from the carbon. So that's it, and that's it. So now you have only carbon and the functional group. There are C2. What C2 means here, that there are two carbon here. Let's put it everything here. So the longest chain I can see, is this one. This is your longest chain here, right? And where we should start the numbering, that's easy here, because this time the functional group is hydroxide and we start on the second position, right? So I'll be numbering it from the left side, clockwise. 1, 2, 3, 4, 5, finally 6 and 7. So that's the number, right? Now, these are the functional group. These are the functional group, and this one is a alkyl group. This one is a alkyl group. So I'm going to write, because alkyl groups are always prefixed, so this must be used as a prefix. So I'm writing 5-methyl, I'm writing the name over there. 5-methyl, now the 7 heptane is for the 7 carbon. 1 OH is on the second and second is on the fourth. So that's going to be like 2, 4 diol. That's it. So 5-methyl, yes, I made a mistake. This is ethyl here, not methyl. So this is a ethyl group. Why ethyl group? Because it has 2 carbons. So 5-methyl heptane 2,4-diol is the name of this particular compound. Right? I hope you have understand. So let's take you through the next topic, which we have already there. So I'm taking this off. Okay. What third one is, like I said, don't bother about hydrogen. So I'm also wiping them off. Right? That's it. So what you have only 4 carbon. Can I make it a bit more complicated? Like let's put this something like this also, like CH3 and like CH, like C2H5. I hope you can see that. Now, the thing is 1, 2, 3, 4 is the longest chain there, but 1, 2, 3, 4, 5. This is the longest chain here. This is the longest chain here. So longest chain now you have right over here. This is your longest chain. So you have a methyl here, you have a methyl here, you have a hydroxide, you have another hydroxide. So the name is going to be, like 1, 2, 3, right? So 1, 2, 3, that's going to be 3, 3 dimethyl, 3, 3 dimethyl, and 5 carbon represent to pentane, and they are on the second position. So 2, 2 diol. That's it. So 3, 3 dimethyl pentane 2, 2 diol. That is the IUPAC name for this particular compound. What now we have some benzene based, alcohol, which is also called phenol, right? So let's talk about this first one. The first one has a methyl group and a hydroxide group. But you do remember that this is not a major functional group, OH is. So this will be numbered, this carbon will be numbered 1. So this is your 1 and this is your 2. So what you can do, you will be writing 2-methyl right? And phenol, 2-methyl phenol, because this represents to phenol. Benzene with OH is called phenol. This can also be written as 2-methyl, right? 1-hydroxy should be 1-hydroxy, because alphabetically, let me write 1-hydroxy 2-methyl benzene. That is also the IUPAC name. Why I did that? Because hydroxide is written with H, which comes before the M alphabetically. So this is also the name 1-hydroxy 2-methyl benzene. This is for the the first one. We have the first one is here because it has more priority. So 1 and 4. So what I can do, I can write it like I can write 1-hydroxy 4-methyl benzene. But like I said, another name which is going to be 4-methyl phenol. 4-methyl phenol. That's it. So that's the second part it was. Let's go for the third one. Now what you see out here, that there is a functional loop, and there you have to pay a bit of more attention. So this is for sure going to be the first carbon. Now you have two different directions coming up. You have either this way or you have either this way. Now you have to use a rule called lowest sum rule. Lowest sum rule. What this lowest sum rule is? I will number all these positions on both directions. So 1, 3, 4, 5, 6. So in anti-clockwise, you have 1 plus 3 plus 6. 1 plus 3 plus 6, and that's 10. But let's go into the clockwise. So now you have to wipe them off so that it doesn't confuse you. So this is your 1, 2, 3, 4, 5. So in clockwise, it's 1, 2, and 5. 1 plus 2 plus 5, and that's only 8. So what I will do, I will not use this one, but I will use this one, because you have the lowest value coming out in anti-clockwise, right? And based on that, let's write the name here. Let's write the name of this particular compound. So what name is going to be? This is going to be 2,5-dimethyl phenol. 2,5-dimethyl phenol, like I said, but it can also be written as 1-hydroxy 2,5-dimethyl benzene. So these are the two IUPAC names here. I hope you have understand that lowest sum rule. This was really very important, and at so many occasions you may be confused which way you have to go. Right? You have to go from left to right or from right to left. If there is any confusion, use this rule, lowest sum rule. And what you have to do, you have to sum all the positions where groups are present, and then you can decide based on the lowest you get. So, okay, we have this very last and then I will talk about the ether. So like I said, alcohol is a major group, so this is going to be like 1, right? In clockwise, anti-clockwise, if you move 1. That's 2, and 1, 2, 3, 4, 5, 6. That's going to be 6 here. But so this is going to be like 1 plus 3 plus 6 plus 8 going to be 9 here. But in this direction, what is happening here? 1 plus 2 plus 6. 1 plus 2 plus 6. So that's also going to be 9. So there is nothing wrong if you take any direction. So in both direction, it's coming out to be 9. I hope so. 1, 2, 6. 1, 2, and 6. So in any direction you can take. So what the name is going to be? This is going to be like 2,6 dimethyl phenol. Or it can be like 1-hydroxy 2,5-dimethyl benzene. Benzene. Right? So that's it. What I'm doing here, I'm talking about the ether. So in ether, the first example I see is, I'm not bothering about hydrogen anymore. So CO, C, C, and then there is one more C and another C is right here. Okay, what second one is? This one is your first one. Let's take the second one. Second one is, C6H5, C6H5, O, and then C2H5, C2H5. The next is going to be, C6H6, C6H6, O, and finally C7H15, C7H15. There is one last also, D1, it says C, then there is another C with O, and then you have C, C, and C. One last is here, another C, right? So I'm going to do these examples for making it. But before that, I need to repeat just a fact about the ether. What ethers are, I've already told you in the previous video. Ethers are a group of compound where oxygen is present as a functional group, and oxygen is surrounded by alkyl group or aryl group or a mixture of both from both sides, right? And it is basically also called alkoxy group or aryloxy group, right? So let's do the naming and get it through the whole. In this case, one thing is for sure, you have to understand that on one side of oxygen, you have least number of carbon, and one side you have more number of carbon. So the side where carbon is least, that will become alkoxy, that will become, oxy. So this become, methoxy. Why methoxy? Because it has only one carbon with oxygen. So methyl with oxygen become methoxy. And there you have the longest chain 1, 2, 3. So this will be your methyl. This will be your methyl. I'm trying to help you as possible as methyl. And as you know that 3 carbon chain are called propane. 3 carbon chain are called propane. So how the name is going to be? We will be writing 1 methoxy. So the name finally coming out to be 1 methoxy. Why 1 methoxy? Because on first carbon you have methyl and oxygen, and then 2 methyl, and then propane, 2 methyl propane. Now try this one. What you see, there are 6 carbon here. So there are 6 carbon and there are only 2 carbon. So as I said earlier, this will become ethoxy because oxygen is included to the side where carbon is in least number, right? So there are 2 and there are 6. So oxygen will be included in the least number of carbon. So this becomes ethoxy. So this is your ethoxy. Why it's ethoxy? Because it has 2 carbon. So this is ethoxy. And of course, this one is going to be benzene. So what I will write? I will write, ethoxy benzene. Ethoxy benzene. That's it. Okay, let's talk about the second one. There you have 7 carbon. There you have 7 carbon and there you have 6 carbon. Now this oxygen will be included to the 6 because 7 is longer. So this become, 1 because there are 7 and everything is here on the first one. So 1. Another very important thing is that if oxygen is with the benzene, you need to understand, if oxygen is with the benzene, the name becomes phenoxy because it represents to something similar phenyl. So let me write this, 1 phenoxy heptane. Why heptane? Because there are 7 carbon here, right? And let's come out with the last one. So as you see, there are 2 carbon only. So that's going to be ethoxy, and there are 1, 2, 3 carbon. 1, 2, 3, 4 carbon. So this is going to be like 2, like 1, 2, 3, and 4. So this is going to be 2 ethoxy, and butane. 2 ethoxy, butane. That's it. So this is how ethers are named. I'm taking a couple of example also, if you have name here 1 ethoxy propane, right? Now you have to write the structure here. So this is going to be like, first thing you have ethoxy and on the first carbon. So propane is the parent chain. This is your parent chain. This is the parent chain. So a parent chain has propane, so there will be 3 carbon. So 1, 2, 3, right? And in case you want to write complete, this is going to be like CH, CH2, and finally CH3, right? And then you have oxygen with 2 carbon. Oxygen with 2 carbon, right? In case you need to write the formula CH3, and that's going to be CH2. This is also going to be CH2 here. So 1 ethoxy, there you have the ethoxy. And propane, you have this one as propane. So this is your propane, and this is your 1. Why this is on 1? Because 1, 2, 3. So 1 ethoxy. So this is how you can write the structure taking the name. 2 ethoxy, 3 methyl pentane. Right? So like I said, this is your parent chain. The last word represents to the parent chain. What that means? There are 5 carbon in a sequence. 1, 2, 3, 4 and 5. On the third one, there is a methyl. On the third one, there is a methyl here. So 1, 2, 3, this is a methyl. And on the second, there is ethoxy. So on the second, there is ethoxy. So what I'm going to do, I'm going to write ethoxy like this. And then I will also place, this is what the thing. So this becomes 1, 2, 3, 4 and 5. So this is your ethoxy here. This is your methyl here. And this is your pentane. Let's check out in case you need, to make sure I'm doing exactly the way you are expecting. So these are some of the examples, I tried, to do for you, where the main concern was to make you understand the basics of nomenclature of, alcohol, phenol and ether. Ether is going to be something new, so you need to practice a little bit more. Though it's not that difficult, this is definitely going to be easy. And with that, I have to wind this off. In case you have still problem with nomenclature, let me know. Then I will try to make something else also. So with that, I must say thanks for watching.